নেক্সট গ্রুপ বি। গ্রুপ বিতে 5টা কোয়েশ্চেন দেওয়া আছে, 3টে কোয়েশ্চেন করতে হবে, অ্যান্ড ইট ইজ অফ 15 মার্কস। এভরি কোয়েশ্চেন হ্যাজ 5 মার্কস। ওকে,
coming to the next section, differential calculus. Look what is given over here. Question number 2a. Consider the sequence 4n plus 3 divided by 3n plus 4. Okay, এই সিকোয়েন্সটা দেওয়া আছে, এক্সামিন চেক করতে হবে। নাম্বার এ, whether it is monotonic increasing or decreasing. Number B, whether it is bounded above or below. Number C, state whether it is convergent with justification. Okay, so chalo shuru kori amra. We are going to start from here. Xn is equals to dewa ache dekho 4n plus 3 divided by 3n plus 4. Okay, so we can write xn plus 1. What will be xn plus 1? It will be 4 into n এর জায়গায় n plus 1 বসিয়ে দাও, 3 plus 4 into n plus 1 plus 3 divided by 3 into n plus 1 plus 4. Okay, so xn plus 1 minus xn কি হবে দেখো, এটাকে আমরা সিম্পলিফাই করে লিখে দিচ্ছি 4n plus 4 plus 3, that means 4n plus 7 divided by 3n plus 3 plus 4, that is 7. Okay, minus xn, that is 4n plus 3 divided by 3n plus 4. LCM niye now. So what we will get? It will be 3n plus 7 into 3n plus 4. So 3n plus 7, 3n plus 7 cancels. Here we will get 4n plus 7 multiplied by multiplied by 3n plus 4 minus 4n plus 3, 8 to cancel out, মানে 3n plus 7. Okay, simplify করো, দেখো কি পাবে। Just multiply it. 4 3s are 12n square plus 7 3s are 21n plus 4 4 just 16n plus 7 4 28 minus 4 3s are 12n square, 3 3s are 9, that is minus 9n, 7 4s are 28n minus 21 divided by, not here, from here, 3n plus 7 divided by into 3n plus 4. Okay, so 12n square minus 12n square cancel, 21n plus 16n, that is 7, 21 plus 16, that is 37n, and here it is 28 plus 9, that is 37. So it can be cancelled out. Okay, so we will get 28 minus 21, that is 7 divided by 3n plus 7 into 3n plus 4. This is greater than 0, right? So what we get? Xn plus 1 is greater than xn. So sequence xn is monotonically increasing. So our first answer we got. Whether it is monotonically increasing? Yes, it is monotonically increasing. Now we will move to the second question, whether it is bounded above or below. Okay. So sequence xn is equals to it was 4n plus 3 by 3n plus 4. 4n plus 3 by 3n plus 4. Okay. So we can write sequence xn as, for n is equals to 1, we will get 4 plus 3, 7. 3 plus 4, 7. That means 7 divided by 7, 1. For n is equals to 2, we will get x2 is equals to 4 into 2 plus 3, 3 into 2 plus 4. That is 4 to the 8, 8 plus 3, 11. 3 to the 6, 6 plus 4, 10. That is 1, 1.1. Similarly, for n is equals to 3, we will get x3. Okay. So what will be x3? x3 will be like 4 into 3 plus 3 divided by 3 into 3 plus 4. That means 12 plus 3. 15 divided by 3, 3 is a 9. 9 plus 4. Yes, 9 plus 4. 11. Okay. Not 11. It will be 13. 15 by 13. Okay. It is 15 by 13. Like this. Okay. So, the sequence number B answer will be, sequence xn is monotonically increasing and it is bounded below. Okay, because the number 1 is the lower limit and it is increasing in this direction. 1, 1.1, like this. Okay, so it is, xn is bounded below at x is equals to not x, we can say bounded below at x1 is equals to, bounded below at 1. Oh, bounded below at 1. Okay. Now we will move to our third question, that is whether it is convergent or not. Okay. Now mod of xn is equals to what? Mod of 4n plus 3 divided by 3n plus 4. This is equals to 4 plus, we are dividing both sides, numerator and denominator by n. So we will get this, and 3 plus 4 by n. Okay. Now limit n tends to infinity of xn is equals to limit n tends to infinity 4 plus 3 by n plus 3 3 plus 4 by n. This is equal to 4 by 3 because 1 upon n is infinity, n is infinity, so it will become 0. Okay. So the series is convergent. So the series is convergent. Okay. Understood? Okay. Question number 3A. Define a alternating series. So alternating series er definition ki? Suppose here is a series u1 minus u2 plus u3 minus u4 plus u5 minus ... Okay. So this is an alternating series. This is nothing but plus, minus, plus, minus, plus, minus. That means alternately the signs are changing. Plus, minus, plus, minus. Positive to negative, negative to positive. Okay. So the definition will be a series in which the signs of the consecutive terms okay, consecutive terms are alternately positive and negative. Is called a alternating series. Alternating series. দেখো বোঝা গেছে সাইনস অফ দ্য কনজিকিউটিভ টার্মস মানে পরপর যে টার্ম গুলো রয়েছে তার সাইন চেঞ্জ হবে পজিটিভ টু নেগেটিভ নেগেটিভ টু পজিটিভ সো দিস ইজ অ্যান অল্টারনেটিং সিরিজ নাও 3b examine the convergence of the series this okay so দেখো কি সিরিজ দেওয়া আছে 1 minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square plus ... okay so we can write this series as 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus 1 by 4 square plus ... okay so it is an alternating series okay so it is an alternating series look here the sign is plus minus plus minus plus okay so it's an alternating series কিভাবে সলভ করব আমরা ওকে অল্টারনেটিং সিরিজ যে হচ্ছে তার সলভ করার কন্ডিশন হচ্ছে we can solve it by Levine's test okay alternating series can be solved by Levine's test so what is Levine's test in Levine's test we have to check two conditions number one un plus 1 less than un okay so each preceding term should be less than the previous one, that is monotonically decreasing. And number 2, limit n tends to infinity of un is equals to 0. Okay, so let's check it whether the given series follows these two conditions or not. Okay, here un is equals to, we can write 1 upon n square. If we will put n is equals to 1, we will get u1, that is 1 by 1 square, 2, 1 by 2 square. Okay, so un plus 1 will be what? 1 upon n plus 1 whole square. Okay, now we can easily see that 1 by n plus 1 whole square is less than 1 upon n square. No? Right. 1 upon n square is greater than 1 by n plus 1 whole square. Why? Because this lower part is higher. Okay. নিচের পার্টটা যদি বেশি হয় তাহলে কমবে. Okay. This implies un plus 1 less than un. So first condition, the given series is satisfying. Okay. Now we are going to check the second one. Now limit n tends to infinity of un is equals to limit n tends to infinity. Un means 1 upon n square. This is equals to 0. Okay. 1 upon n square, n means infinity, so it is 0. Number 2 is also satisfied. So we can say by Levine's test, so the given series, or you can say alternating series, the given alternating series is convergent. Okay, is convergent by Levine's test. Okay, so this is our answer. See, what is an alternating series and convergence of the series. We don't have to write the definition of Leibniz test, but we must know it. Otherwise, we will not be able to solve this problem. Okay. Question number 4a. State Rolle's theorem. So what is Rolle's theorem? Okay. Before going to write the statement, I want to explain it. Suppose it is a point A and it is a point B. Okay. So AB is a closed interval. This is the sign of the closed interval. And there is a function fx. So if a given function is continuous, okay, if a given function is continuous in the closed interval a to b, f dash x exists in the open interval a to b and fa is equals to fb. Okay, all these conditions should be satisfied. এগুলো সব হতে হবে. Then there exists a point in between A and B. A and B এর মাঝে একটা point পাবো, suppose যাই. You can give it any name. Okay. A xi greater than A less than B, such that f dash of xi is equals to 0. Okay, then a or b এর মধ্যে f dash xi is equals to 0 means we will get a root over here. Okay, now we are going to write the Rolle's theorem. Rolle's theorem. Okay, so we have to write here if fx is continuous, same thing we have to write that in the close interval. Okay, in the close not here, yeah, in the close interval a to b, this is number one condition. Number two condition should be f dash x exists in the open interval a to b and fa is equals to fb. Okay, then there exists a point in between a and b, in between a and b, such that xi greater than a less than b, f dash of xi is equals to 0. Okay, this is Rolle's theorem. Understood? Now for b, find the value of a এর মান বের করতে হবে so that limit x tends to 0 e to the power ax minus e to the power x minus x by x square exists finitely, and also find the limit. Okay, so first of all we are going to write down the given limit over here. What is the limit? I'm going to change the color a bit. Yeah, yes. Okay, so limit x tends to 0 oh no, okay, what happened? Oh no. Okay, f dash xi is equals to 0. So we are going to write down the limit over here. For b we can say limit x tends to 0 e to the power ax minus e to the power x minus x divided by x square. Therefore e to the power ax minus e to the power x minus x by x square. Okay, now if we put 0 put করে দাও এটা হয়ে যাবে e to the power 0 1 e to the power 0 1 1 minus 1 0 and this is 0. So it is a form of 0 by 0. So how we will, it's an indeterminate form. So by L'Hospital rule. So by L'Hospital rule, what we will do? We will differentiate numerator and denominator. Okay, so differentiating e to the power x, we will get a into e to the power ax minus e to the power x, differentiation e to the power x, except differentiation once. And in the lower part, differentiation of x square is 2x. Okay. Now again, if we put 0, the lower part is 0. And if we put 0 over here, the upper part is, this is 1, a minus 1, a minus 2. So it is not formed 0 by 0. It will be formed 0 by 0. Okay. Oh my god, it is 2x. So it will be formed 0 by 0. Eta 0 by 0 hobe if a মানে এখানে 0 বসিয়ে দাও, you will get 1, that is a into 1a minus 0 বসালে e to the power 0 1, so 1 minus 1, that is minus 2. If a minus 2 is equals to 0, then it will be a form 0 by 0. This implies a is equals to 2. Okay. So again by L'Hospital rule. Again by L'Hospital rule, what we will get? Limit x tends to 0. Differentiation of e to the power ax is a into e to the power ax. So a into a become a square into e to the power ax minus e to the power x. Differentiation of 1 is 0. And in the lower part, 2 into differentiation of x, 1. Okay. So now it's completed. So now we are going to put the value of x in the upper part. So we will get a square into e to the power 0, a into 0, 0 minus e to the power 0 divided by 2. This is equals to a square into 1 minus 1 by 2. That means this is equals to a square minus 1 by 2. Okay, we know the value of a is 2. So it will be 2 square minus 1, 2 square minus 1 by 2. This is equals to 4 minus 1 by 2. That means this is equals to 3 by 2. And this is our answer. Okay. Find the value of a so that this exists. So it will exist if a is equals to 2 and the limit value of the limit is equals to 3 by 2. This is our answer. Okay. Question number 5. দেখো কি দেওয়া আছে, find at what values of x the function fx is equals to 2x cube plus 3x square minus 12x plus 1 has maxima or minima, and find corresponding maxima or minima of the function if exist. Okay, so আমরা কি করব, first of all আমরা লিখে নিচ্ছি fx is equals to কি দেওয়া আছে 2x cube plus 3x square plus, not plus, it's minus 12x plus 1. Okay, so we will find out f dash x. Okay, so f dash x কি হবে, ডিফারেন্সিয়েট করো, এটা হয়ে যাবে 2 into 3x square plus 3 into 2x minus 12 plus 0, right? So it will become 6x square plus 6x minus 12. Okay, এবার আবার একবার ডিফারেন্সিয়েট করো, f double dash x কি হবে, এটা হয়ে যাবে 12x plus 6 minus 0. Okay, so we have to find maxima or minima. তো আমরা আগে বের করলাম fx কি, f dash x, f double dash x. For extreme value বলো তো, means maxima or minima. For extreme values of x, f dash x is equals to 0. কি ইমপ্লাই করবে দেখো, এটা হয়ে যাবে 6x square plus 6x minus 12 equal to 0. That means এটা হয়ে যাচ্ছে 2x square plus 2x minus not this, it will be x square plus x minus 2 is equals to 0. Okay, so x square plus 2x minus x minus 2 is equals to 0. This implies x plus 2 into x minus 1 is equals to 0. This implies x is equals to 1 comma minus 2. Okay, so f double dash x at x is equals to 1 কি হবে দেখো, পুট করে দাও, x এর জায়গায় 1 বসাবো in f double dash x. So it will become 12 into 1 plus 6. That means 12 plus 6, this is equals to 18. 18 is greater than 0. So fx has minimum value at x is equals to 1. Okay, again we will find out f double dash x at x is equals to minus 2. What we will get, 12 into minus 2 plus 6, that is minus 24 plus 6. This is equals to minus 18 less than 0. So fx has maximum value at x is equals to minus 2. So fx mean at x is equals to 1, it is, what was the given function, 2x cube plus 3x square minus 12x plus 1. Okay, so it will be 2x cube minus not minus, this is plus 3x square minus 12x plus 1. This is equal to 2 plus 3 minus, what happened? Okay, 2 plus 3 minus 12 plus 1. This is equal to 5 plus 1, 6, that is minus 6. Okay, so F mean is equals to minus 6. Now F max at x is equals to minus 2. কিভাবে দেখো 2 into minus 2 to the power cube plus 3 into minus 2 whole square minus 12 into minus 2 plus 1. This is equals to minus 16 plus 4 3s are 12 plus 24 plus 1. This is equals to minus 16 plus 12 mean minus 4, that is 20 minus 4, 21 will get. Okay, so this is our answer. Okay, and this is also answer, this is also answer. Okay, our question number 6 is here. Using the Lagrange method of undetermined multiplier, find the stationary point of S equal to 2 into xy plus yz plus zx subject to xyz is equals to a cube. Also find maximum and minimum value of S at this point. Okay, so what we have to do here? We have to apply Lagrange method of undetermined multiplier. Okay, and we have to find the stationary point of S. Okay, so what is a stationary point? The stationary point means we have to find maxima, minima, or in point of inflection if there is any. Okay, so for a stationary point, for a stationary point of S, we put ds is equals to 0. Okay, so here is S is equals to this. I am giving you equation number 1, not question. This is equation number 2. Okay, so we are going to differentiate this. What we will get? We will get 2 into xy differentiation, that is x into dy plus y into dx. Okay, okay, so we are going to differentiate s. We have given it equation number 1 and here we have given equation number 2. So from 1 we are going to differentiate. So it will become differentiation of these terms. So differentiation of xy we know x into dy plus y into dx plus differentiation of yz y dz plus z dy plus differentiation of zx, that is z dx plus x dz equal to 0. Okay. Now we are going to simplify it. So we can write y dx plus z dx. We are arranging it as y plus z dx plus x dy plus z dy means x plus z dy plus y dz plus x dz. That means we can write y plus x into dz equal to 0. We can give it equation number 3. Okay. Now from 2 xyz is equals to aq. From 2 we are also differentiating 2. So we will get x into differentiation of yz, that is y dz plus z dy equal to, not equal to, yeah, plus yz into dx is equals to 0. After rearranging we will get yz dx plus xz dy plus xy dz equal to 0. This is equation number 4. Okay. Now we are going to use Lagrange method of undetermined multiplier. So here we are going to take 1 and lambda as multiplier. Okay. Taking 1 and lambda as multiplier. Okay. So we are going to multiply 3 by 1 and 4 by lambda and then adding. So what we will get here? We will get y plus z plus, I am taking this term and this term, y plus z into dx, and here we are multiplying it by lambda, so it will be lambda yz. I am taking it and writing y plus z plus lambda into yz into dx. Okay. Now I am taking this second term and this second term. So I will write x plus z plus lambda xz into dy plus, now this term and this term. So it will be y plus x plus lambda into xy into dz is equal to 0. Okay. Now equating coefficients of equating coefficients of dx, dy, dz to 0. What we will get? Y plus z plus lambda yz equal to 0, right? Here x plus z plus lambda xz is equals to 0, and y plus x plus lambda xy is equals to 0. Okay, this implies 1 upon z, we are going to divide it by yz. Okay, so it will be y by yz means 1 upon z plus dividing it by yz, we will get 1 upon y, and this is equals to lambda, and we are taking this right hand side of this equal to sign, so it will become minus lambda. Okay, similarly here we will get 1 upon z plus 1 upon x is equals to minus lambda, and here we are getting 1 upon x plus 1 upon y is equals to minus lambda. Okay, now all these terms are equal to minus lambda, so 1 upon x plus 1 upon y is equals to 1 upon z plus 1 upon x is equals to 1 upon z plus 1 upon y. Okay, this implies 1 upon x is equals to 1 upon y is equals to 1 upon z. This implies x is equals to y is equals to z. Okay, so we know x, y, z is equals to a cube. So from here we can get x cube is equals to a cube. This implies x is equals to a. So x is equals to y is equals to z is equals to a. That is all the okay. Now what we can do? We can find out del s del x means differentiation of s. Okay, and again we are going to find sit there. Okay, now we are going to find out del s del x, differentiation of s with respect to x, del 2s del x square, del 2s del y square, del 2s by del x del y. Okay, and before that we are going to use the equation number 2 as here. We can express x, y, z is equals to a cube as function of xy. We can express okay, we can express z as x and y. So xyz is equals to aq implies y x into del z plus z into del x equal to 0. This implies del z by del x equal to minus z by x since y not equal to 0. Similarly, we can find out del z by del y is equals to minus z by y. Okay? And we are going to use this del z by del x and del z by del y in all the other derivatives of s where we will use it. Okay? Yeah. So we are going to use yeah, okay. So we are going to use this as equation number 5. Okay. So now s is equals to 2 into xy plus yz plus zx. So del s by del x is equals to, here we are going to differentiate it with respect to x. So we will get 2 into, I am keeping y, differentiation of x 1 plus y into del z by del x plus z into differentiation of x1 plus x into del z by del x. Okay. So we will get 2 into y plus z plus y plus x into del z by del x. Yeah. Here we are going to use del z by del x equal to minus z by x from 5. So we will write 2 into y plus z plus y plus x into minus of z by x. Okay? Yeah. So it will be 2 by x into, multiplying this by x, we will get xy plus xz plus minus minus, we are getting yz minus xz. Yeah, minus xz. This is equals to 2 by x into plus xz minus xz cancel out. So it will become xy minus yz. So we can write it 2 into multiplying this 1 by x over this. So we will get y minus yz by x. Okay. So here we got del s by del x. Keep patience while doing this type of sum, because if you will make a single mistake, then your all efforts will be wasted. Okay. Now we are going to find out del 2s by del x square. This is equals to 2 into, again we are differentiating it with respect to x, and here it is y, so it will be 0, minus y, we are taking it as constant, yz. Differentiation of 1 upon x is minus of 1 by x square, so it will become plus, and here it can write x square, minus, again we are writing minus y by x into differentiation of z, that is del z by del x. Okay, again we are going to use del z by del x is equals to minus z by x from here. So we are going to simplify it as 2 into yz by x square minus y by x into minus of z by x, right? So minus minus plus, we are going to get 2 into yz by x square plus yz by x square. So it will become 2 into 2yz divided by x square. So finally we got 4yz by x square. Similarly, we can find out del 2s by del y square equal to 4 into, when we are differentiating it, we have differentiated it with respect to x, we got yz. So we are differentiating with respect to y, so we will get xz over here. And when we are differentiating with x square, we got x square as a numerator. So not numerator, it is denominator. Okay. And again here it is y square. So we are getting it here, y square in the denominator. Okay. Now del 2s by del x del y is equals to, we are going to use this one, del s by del x. We are differentiating it with respect to y. Okay. So here it is 2 into y minus yz by x. So we are using it, we can write 2 into differentiation with respect to y. So differentiation of y is 1 minus z by x into differentiation of y is 1 here. Again we can write minus y into z, z, del z by del y, and this is y by x, it will be as it is. Okay. So it will be 2 into 1 minus z by x minus, okay, yeah, understood. We have kept this y by x and we differentiated z here, okay. And now we are going to put the value of del z by del y, that is y by x into del z by del y means minus of z by y, okay. We are using curly braces. So now we are going to simplify it. 2 into 1 minus z by x minus minus plus, this y and this y is cancelling out, so it will be z by x, again minus z by x plus z by x cancels, so it is 2, okay. So up to this what we did, we have taken ds0, we have differentiating these two equations, right? We have differentiated these two equations. Then we take these multipliers 1 and lambda, then equating coefficients, we got this results xyz equal to a. We express z as x and y, okay, that is del z by del x minus z by x, del z by del y minus z by y. Then we differentiated s with respect to x, del s del x, del 2s del x square, del 2s del y square, del 2s del x del y. Okay, understood up to here? Now we are going to see the results for x is equals to y is equals to z is equals to a. Del 2s by del x square. What we will get? 4 into yz by x square. All are a, so it will be a square by a square. So it will be 4. Similarly, when we put del 2s by del y square, we also got 4 into a square by a square. This is equals to 4. And del 2s by del x del y, we already got the value 2. Okay. Okay. Now we are going to use the multiplier formula, that is del 2s by del x square into del 2s by del y square minus del 2s by del x del y is equal to what we get? Del 2s by del x square 4, del 2s by del y square at x is equals to y equal to z equal to a. All the values are at this point. 4 into 4 minus, that is del 2s by del y square 2 square. So we are going to get 16 minus 4. This is equals to 12 greater than 0. That means the given function has minimum value at x is equals to y is equals to z is equals to a. Okay. And also del 2s by del x square is positive, so it has minimum value at x is equals to y is equals to z is equals to a. Okay, so we have to find the stationary point and maximum and minimum value. So we got minimum value at this point. Okay, so what is the s minimum at this point, this is equals to 2 into xy plus yz plus zx. This is equals to 2 into a square plus a square plus a square. This is equals to 2 into 3a square. This is equals to 6a square. Okay, so this is our answer. It has a minimum value when x is equals to y is equals to z is equals to a, and the minimum value of the function is 6a square. Okay, understood everyone? It's a big problem. Okay, so keep patience, concentrate well so that don't get confused at any point. Okay, just see. Okay.